G'day folks, it's Dragon doing a bit of a gear review on a couple of, well it's the same one actually, small stove made out of tin cans that someone gave me a couple of weeks ago. They couldn't get the things to work properly, so had a bit of a fiddle around with it, and it's a bit of a review on it. And basically that's about the size of it. Has a little pouch on the front there, probably a stick box of matches or something in there. Not very big. And around the back it has these mil-spec clips on there that you can hang off your belt or off your webbing or your backpack and that sort of thing. It's fairly compact. It's probably not the sort of thing I'd use initially, but look at options. The canvas carry bag clips down like that so nothing falls out of it. When I first looked at it, I thought, well, on the net you've seen different types of stoves made out of cans, of hobo stoves and rocket stoves and that sort of thing. And when I first initially looked at it, there were some design flaws in it, because the guy couldn't get it to burn particularly well or sustain a burn in it. Now, if you look at the way wood heaters and wood stoves are designed, you've got the fuel chamber or the fire chamber, you've got an inflow of oxygen or air, put your fuel in the chamber, and light her up and away it goes. That's only two factors. The other factor is that's quite often overlooked, and I've seen it in many designs and the way people build these types of stoves, be that a hobo stove or a rocket stove, is the way the gases or the smoke are vented. And it seems to be quite a common fault with not so much the designs of them. I think it's the understanding and the concept of how they're built and when people build their own. Works in the same way as a wood heater or a wood stove. You've got to have the correct combination for the wood to burn with the air. It's like a triangle of fire. You've got to have air, you've got to have heat, you've got to have fuel. But there's a fourth component too. It's a chemical reaction through the combustion process that produces the heat, and of course a lot of waste gases, smoke and stuff like that. And quite often you'll find that, for argument's sake, that's a billy or a pot or something, you're heating up water or something in it. You put it on top, the next thing you know it dampens the flame down. Why? Because it's restricting the flow of gases and smoke out of the top. And what I found with this particular one was it pretty well snuffed it out, what I call a constipated burner, because we've got all this fresh stuff in there burning away. Put that on top of it and all of a sudden the burn rate slows down, and in some cases it just goes out. I've seen similar things happen with hobo stoves and rocket stoves and similar designs. This one has two parts or three parts. It's made from two cans. You've got the outer can, which from the design of the lip on it has a lid. It also goes on it. It looks like a paint can. There's also an inner can in there. And when I initially looked at this, I thought, well, how do you get that can out? I couldn't find any well spots, so what I did was force of hand. That's the second can that goes inside. That's your fire chamber. It looks like a normal food can, I'd say probably vegetable or something, and it's just pressed into the inside lid of that. Quite solid. A couple of things I noticed straight away with a design fault in this. On this one you've got large holes drilled into the bottom of it. or cut or pressed, I'm not sure which. But anyway, they're large holes, probably around about ½ inch in diameter. On the back of it, there's no holes. So that gives you an indication that you've got to turn this towards the wind to get the airflow into the bottom of the chamber. The chamber itself, if we look at it, can we get a close up of that? You can see there's a lot of small holes in there. Basically that's where the fuel sits, right inside this chamber. We've got small holes on the side, much smaller than these ones. We've also got holes in the top all the way around. Probably around about ½ inch in diameter, maybe a bit less. One of the problems I found with this, I did a couple of burns on it, was fill this up with fuel. Now, the design of these is to be very fuel efficient, using small twigs and that sort of thing, which is great. It's a great idea. Build a fire, make a fire very quickly, using maximising fuel efficiency and resources. When I fired this up, there was a couple of things I noticed straight away. These holes in the bottom here, while the air is being drawn in, when you initially light the fire, that's great, but as the fuel burns down inside, forms ash and a little bit of charcoal. That blocks these holes up. There's nowhere for it to go. So it's restricting the air supply coming into the burning fuel. I also noticed too that the holes around the side, the bottom here, also filled up with ash. That restricted your airflow into it. So essentially the fire in there went out and started to smoulder. Now the instructions that came with it also said you can use wood chip, fill it up to the bottom of the top holes, pour some flammable liquid in there, alcohol, kerosene, whatever you want, and light her up. I decided not to do that because I wanted to test out the actual design of it and find out where the flaws were. What I did notice when it was burning, before it actually went out, was that there was a slight wood gasification going on in there too, because as the gases rose up, there was a secondary ignition of the gases by air coming in through the holes in the top here, sort of like an afterburn. So there was a little bit of wood gasification going on in there. It wasn't sustainable, it went out. So the overall design of this was, it's completely wrong. You don't have a clean airflow coming in. You've got a problem with an ash build-up blocking up your air vents at the bottom. And of course, this is a great idea in theory. Sits on the top of that, put your pot or your pan on there, and the holes drilled in the top, again, restricted the outflow of hot gases and smoke. Feed the fuel in through here, and believe me, when I was doing some testing on it, you need, well, pretty much a fast conveyor belt system because you're just pouring fuel into it. I tried newspaper, dried leaves and that sort of thing, to the point where the ash built up and it went out. While it was burning, you've got to keep pouring the fuel in, twigs and stuff about the size of toothpicks and things like that. Okay. The second one, I pulled it apart and started to do some modifications on it. The modifications was to improve the airflow into the bottom, into the fire chamber. And what I did was just pull this out. First off, I'll start with the outside piece. The holes on the bottom here, I reamed them out and made them bigger, and I also took them full circle right around the bottom of the can. Okay, then it looks a bit messy. I drill some more holes in the bottom of the fire chamber, hopefully to allow more ash to fall through and not block up the air intake at the bottom of the chamber. I also made the air intake on the bottom of this much bigger too. Again, on the top I drilled out the holes a bit more and made them bigger. Now, after doing that, I did get a better burn rate. Not entirely successful, but it was certainly better than the original design. But while I was doing it, I also noticed too that the can fire chamber, that's about the size of it, that's about the length of it. Now you notice the holes, air holes on the bottom of this one, somewhat lower than the air holes on the bottom of this one, so you haven't got a clean airflow into the fire chamber, causing a lot of turbulence, and in some cases you get small pockets of vacuum where through the air turbulence as the material is burning, where it doesn't burn efficiently and causes all sorts of problems. So that was another design problem that I found. So for the equipment review on that, yes, it's got this on here. Pot sits on that, feeds your fuel in through here. You'll notice the holes on top there are very small, much smaller than the ones I modified, and certainly with the original design. You've got all this air coming in, and you've got a huge expansion of hot air and gases coming out, and virtually nowhere to go. They've got small holes here which helps it, but it's not big enough for the expanded hot air and gases to come out and clear the fire so it can burn more efficiently, effectively slowing down the burn rate or even putting it out. So that's another design problem that I've got to work on. I've seen it happen on rocket stove designs. I cut lips in here to let the gases escape and that sort of thing. And again, if you look at a chimney design on a fireplace, it's virtually straight up, so you can't restrict the flow of hot gases and smoke out of the top, because remember, it's expanded, it needs to get away quickly, so it draws more air in as the fuel burns, makes it more efficient. Another thing I've noticed too, that a lot of people, and this is just an example, if that's a pot or a billy, or might be a small pan you want to cook on, it's roughly the same diameter as this one. You put it on top there, and again you've got this dampening effect of the exhaust gas coming out of the fire chamber, which slows down the burn rate and pretty well much puts it out. Okay. The other thing I found with this particular design too is because of the size of the can, yes, it's compact, not a problem, but because of the diameter of that can, you need a good flat surface. If you're putting a big pot of water on there, or something heavy on there, you're cooking or whatever, that's not really very stable. It can fall over very quickly. Okay. The theory is good, the concept is good, in practicality, the design really needs modifying. In fact, it's modified as much as I can go at the moment. So I'm looking at a new design. With the view of this air intake and outventing of hot air and gas and smoke problem. It seems to be a common problem with a lot of homemade hobo stoves and rocket stoves and similar stoves like that. Good points. It's very compact. When it's all put back together, that's all.
Can you?
Just do that again for the camera. It all goes back in there. Very compact. Like that. Has a lid on it. You can use that lid to put the fire out if you can get it going properly. And also there's enough room there to store some of your fire lighting equipment gear, flint, steel, maybe a bit of char or a little bit of dry tinder or something like that. In that respect it is good, very compact. So that's about it, folks. We're going to try and do over the next couple of days is rework the design on these. I don't know whether I'll go with a double chamber or just work with a single can like this. We'll see how we go. But anyway, that's a gear review on that. Modifications I did get a bit of better burn rate, but it still wasn't sufficient, not sustainable. I did try to boil some water on it. It was a can about that size and only managed to get it up to, well, the water was too hot to put my hand in. It was just a very, very low simmer before the fire went out in the chamber because of the ash problem blocking up your air intake and also the outgassing of hot air, vapour, fuel, fumes and smoke and that sort of stuff. Alright folks, so that's a gear review on that. I've really got to sit down and work it out and hopefully come up with something better that works. Thanks very much for watching.